Or one last life or death question, and then we'll move on. All right, then. Thank you so much, Sam. Brad, you're up.
Is that visible, and can you hear me?
I can see your screen. I can hear you just fine, and you need to introduce yourself.
Brad Nelson, tinkerer with various fourthy things. Today I'll be talking about graphics in micro uEforth. Background for those of you who haven't sort of caught some of the prior things I've worked on. There is a version of an uEforth variant that I worked on for ESP32 called ESP32forth that's out there. Although it is generally used by folks that are focused on targeting ESP32, it is actually multi-platform and has support for both Windows and Linux to varying degrees. In the background, I've been meaning to sort of improve its capabilities for some time. And one of the things on my list was graphics, and the HERT challenge, of course, prompted me to think, this was a good time to finally get around and add that. And in general, it was on sort of my set of goals to begin with this particular implementation. The interesting things about micro uEforth are that it tries to have a fairly minimal core and then sort of boot everything from mostly from Forth source that's embedded actually in the system. So every time it starts up, it's actually sort of booting itself from source and built on a handful of words. The set of core words or built-in words has actually grown recently. In reaction to having, the trouble with having users in ESP32 is that then they come back with feedback. And one of the concerns was booting from source. I was using a lot of RAM on the ESP32. And so I moved more of the core into built-ins. And so, but philosophically, one of the main sort of design goals was to not have a ton of C code and have a lot of Forth code. So it's built in C. And so bindings for programming languages or for graphics are something that has to be sort of done from some fairly minimal things. On POSIX, you've got DLSym to pull symbols in and get proc address on Windows. And so everything else is sort of built up from there. I see. Is there a question in the chat? No, that's not me. So anyways, goals are, I wanted to have something that has the same interface on Windows and Linux because I go back and forth and I use Windows subsystem some, but I wanted to be able to do Win32 directly. I wanted to make sure that for X11 that I didn't do anything that caused the system on startup to sort of depend on X11. So it needs to be able to sort of dynamically use X11 if the program uses it and otherwise not. And then I wanted to also limit whatever memory is being used so that it's not allocating a bunch of things and doing them unconditionally at startup. And so for both of those reasons, I wanted to rasterize in Forth just to see if I could do it and see what the performance would be like and all of that. And of course, the consideration in all of this is I'm got folks that are downloading the thing and building against it. I wanted to make sure I didn't break ESP32forth. And I'd recently gone through and done a bunch of work around the testing for ESP32forth to hopefully make sure that I wouldn't break anything in the process. So fingers crossed I didn't break anything, although I did find one thing I broke this morning. So, but it's fixed now. So I see things in the chat, but I'm going to assume that's not. Okay. Cool. So the way that this sort of layer that I've added is structured is I've got a bunch of graphical state variables and then a rasterizer that is common between Windows and Linux. So it's the same piece of code that's used in either case. And it tries to depend, the rasterizer tries to depend mostly on the state variables and not on sort of any of the graphics calls. And so there's this weird low and higher level split, because you've got low level words that sort of call into the APIs to actually get windows and put things on the screen and so forth. And then there's these sort of nominally higher level things that are sort of there for the rasterizer, but it's a rasterizer, so it's actually low level. So it's not really, they're both kind of, as is often the case with Forth, there isn't really the sort of layering that you might expect. And then there's separate sort of re-implementations of the same small set of words for both Windows and Linux. So let's talk about the low level part. So the interface, I wanted to have a very simple interface that I could sort of use over time. And I had long ago, for those of you who might have seen, I did a sort of some experimentation with fonts way back, and I kind of used that as a starting point. But the idea is that it should be easy to use in a couple a screen full of words to understand to use it, at least for sort of each layer of it. And so to get a window, you just ask for a window with a given width and height. If you pass in -1 for the width, it'll give you a full screen. It'll give you a maximized window, not a full screen window. And then the idea is just that it gives you raw access to a back buffer that you can get a particular pixel on. It's a 32-bit value that you can manipulate, and then you can find out what size the window is, and then when you're all done, you do flip to blit it to the screen. And the reason for the indirection is that both with X11 and with Win32, you don't really want to be touching their buffers directly. You want to do something in a memory buffer and then sort of flip things over when you're done. There's some very simple event handling. It probably needs some more work to be more consistent, and especially better for some things with keyboard. But the basic shape of it is that you can either sort of block and say, I'm going to wait until there's an event from the graphics system, or you can pull and say, okay, check to see if there's an event, but it return immediately. And regardless, you either come back with one of these event constants. So you either things are idle or something has resized or something is exposed, and so you're just sort of finding out what's the most recent thing that's happened in the UI. And then there's some info about what's going on in the world. So where is the mouse at? What was the last character typed? And then what is a key down, because that's useful if you're doing something interactive. Sometimes it's useful to not have to have bookkeeping code everywhere to keep track of which keys are down. And then just character events if somebody's typing versus like an up or down event. And then I just treat mouse buttons similarly to keys. So that's the interface. And then the high level interface is built on top of that, or at least that sort of the simple core of that. There's a pen color, which is just literally a value. And one sort of thing that I did in the process of this is I actually spruced up the performance of the implementation of value in 2 inside of Micro uEforth, so that it is a little bit smarter. There's a built-in opcode for setting a value so that you can do that in one instruction, or one virtual instruction instead of multiple. And when you access it, similarly, it's a single instruction. And then you pick a color, and then you can draw a box. And it's a clipped box, because it's a real pain if you have boxes that will fail if they go off the edges. And so it handles the clipping internally. And then there's support for transformations. And transformations, in this case, I decided to settle for scale and translation. So you can scale by arbitrary rational constants, and then you can translate things around, and that allows you to build a transformation stack so that you can build hierarchical things. So the car, and then the wheels of the car, and then multiple instances of that car, and move them around, and so on. And so there's 2 words to sort of push and pop that stack, a little bit like also for folks who've seen PostScript. And then there's some convenience words. Viewport does a thing that I every time I do anything with graphics, I struggle with, which is that you usually want to have some particular coordinate system, but your window may or may not be a rectangle with that particular aspect ratio. And so the sort of nice, elegant thing to do is to center your desired aspect ratio in the middle of that window, and then sort of fill as much space as you possibly can. And I'll show you that in a minute. But Viewport sets that up so you can say, I want my coordinate system to be, you know, from 0 to 640 by 480 or something. And then also there's a word to flip the coordinate system, which by default has the y-axis going down, but you can flip it so that the y-axis goes up. And then it's convenient, especially with that transformation stack, to have a word to be able to take a coordinate that's in screen space and convert that into the coordinate space that you're currently in. That's particularly nice if you've got, say, the mouse position and you want to figure out like where does that relate to the current frame of reference. So you can do things like set up your viewport, draw a box with the assumption of a particular size screen, and things sort of work out nicely. You can add transformations in to slide things around, and so on. And then you can build up hierarchical things and draw the wheels of the car at different offsets from each other and so on, or scale pieces of something and have them scale up. And the scaling, by the way, is it's a ratio, so the numerator and denominator. And then internally, everything is being kept track of with 16 bits of decimal that is being bit shifted away. So, but you don't have to. The nice thing is I've managed, I think, with this word set to structure it so that you generally don't have to think about that. You can just say, well, I want my coordinates to be whatever coordinate system, and then you're working with integers and then scaling factors that are integers. So the implementation is actually not too bad. It's just a bunch of values for all that state that I mentioned with a lot of these things about events. There's a back buffer that gets initialized by the particular platform implementations, and then just lets you go reach in and grab particular pixels. And then a sort of a core primitive is to be able to draw a horizontal line. I sort of use that as my baseline primitive. So you pick a particular coordinate system and a width, and then you draw something in the current color. This is what I initially used, and it's actually not too bad in terms of performance. That 4next loop is relatively efficient. But I did eventually decide that it would be nice to optimize this. And so I added an opcode that I called fill32 that takes an address and a 32-bit value and then fills in some number of them. And that lets you rewrite this to this and rely on a tighter, more efficient loop in C. I want to say it's somewhere in the order it's only maybe 5-6 times faster. It's not that much faster. But a lot of, I think, the performance, you would expect a bigger performance difference, but I think some of it just comes down to sort of cache locality. And if you're touching the right piece of memory, it doesn't matter as much the overhead of the fourth loop. And then drawing a box that's clipped, this is a bit of a screen full, but it's not too bad. I mean, you're basically flipping. I take into account the possibility that you flip the axes, and so I have to flip left and right to get everything in order, and then I have to. This is the min and the max is the clipping, and then if after you're done, there's nothing left of your rectangle, then you know you can exit and not draw it. Otherwise, I transform it back into left and right and top and bottom, and then draw a bunch of horizontal lines going down. And then this gets wrapped externally as something that takes into account the current transformation. And so the current transformation is just at any time stored as a scaling factor and a translation in X and Y, and then a shift. So transformations are not bad. It's just a simple implementation of a separate stack, and then pushing those transformation state variables, and then similarly just undo things for the to get out back out to screen space, and then this is translated scale, which are also not bad. Viewport's a little bit messy, and I feel like I've written this computation a gazillion times in my life. various reasons to be able to figure out where to put that box in the middle. And so it'll be nice to have that built in, so I don't have to think and just say, okay, I want 640 by 480, make it as big as possible inside of this window. And then this is probably, actually this could probably be collapsed into one translate in a scale, but I'm simple-minded and did it as two translates in a scale. Interfacing to X11 and Win32 actually took the bulk of the lines of code if you're counting such things. There's existing support in micro uEforth for binding to various shared libraries, and so I pull in X11, pull in a bunch of the bindings for each of the words. You specify the number of arguments that get passed in, and then you go and do X11 to initialize things. Windows presents an interesting wrinkle, though, and there's a little bit of this in X11 as well, which is that these although there are API calls that you can make to draw to X11 or Win32, they make the assumption that you have access to C structures. And there's a bunch of different ways to do this. In past, when I use gforth to do things like this, it has a nice facility where you are able to basically have little snippets of C code that it on the fly compiles. But that's kind of a pain, because then you have to go reach out and run a compiler, and the first run is slow and all of that. And so I decided, well, I'll bite the bullet and implement something that is a sort of minimal compatibility layer for C structures. So I can just respecify the handful of structures that I care about. So typical structure would be like, if you want to specify a window class, you want to define a new type of window in Windows, you need to have a data structure. And the main sort of fussy thing about it is that you have to get the alignment right. So if you have like a 16-bit value, and then you have, say, like a pointer that maybe is a 64-bit value, there needs to be padding in between so that 64-bit things are aligned with 64-bit things, and so on. And so there's a fairly straightforward rule for how this is done. X11 has these two. In fact, it actually has them even worse. It has these big structures. And unfortunately, a lot of them, you'll notice that one problem you've got with structures in Forth is that you need now you've suddenly got namespacing and scoping problems. So my simple fix for this is to just wrap them in a vocabulary when I care. And so I have a structure word that starts a new structure, some field words that add additional structure fields to this structure. And then when you invoke one of these words, it assumes that you have a pointer to an X key event in this example, and it will get you the address of that particular field that you can then access. And then when you call the actual structure method, it returns the size of the thing, so you can allocate them and so on. So I hide these away in vocabularies as needed. This wasn't too bad to build up. I have to keep track of two things. I have to keep track of the last alignment as the structure gets built up, and then you have to keep track of the size as you go. And so I keep track of the last alignment sort of in the inside of the word, and then each of the type words have to know two things. They have to know their size, and then they have to know their size, and then they have to know their ideal alignment. And so, for example, if you're on a 32-bit system and you have an 8-bit type like a 64-bit number, you actually don't necessarily align it to 64 bits. And you'll like this. You have to mirror what the C compiler would do, and the C compiler will say, "Oh, you're on a 32-bit system, so 64-bit things don't need to be 64-bit aligned." So you need to mirror that. So that's why there's one of these for each. Interestingly, I learned a thing I didn't know before, which is that somewhere while I wasn't looking on some of the POSIX implementations or Linux implementations, they've actually made a long 64-bit. I had internalized in my head, oh, longs are, despite, whatever, that I'd assume they were typically 32-bit, and that's true on Windows, but on it seems that in many cases you'll get a 64-bit long. So I actually also added an opcode to the language to find out what the size of a long is on this particular platform. And then building the structures is really not bad. You can just sort of accumulate things inside of the structure as you go. You need to do a little bit of bookkeeping to keep track of alignment, and then you can have some creating words to build fields. One last challenge with all of this, Windows callback. So I don't yet have an interface that lets me cleanly support a callback from arbitrary code on micro uEforth. And I didn't really want to cross that line because, unfortunately for Windows, it turns out there's actually only one kind of callback that you actually care about. There's a thing called a window procedure, and the window procedure lets you hear back when there's a Windows event, and it has a fixed signature, and you can assume a lot of things are going on at the time when they happen. And so you get in, your particular window handle, and initially you don't actually get to pass any extra data. So how do you string this together? It turns out that you can guarantee that the very first event called, or at least an early event called, is this non-client create event. And there's a extra parameter that you can pass when you create a window that will contain arbitrary user data. You can get that arbitrary piece of user data. You can then squirrel it away inside of a separate region associated with the window. And then from there on, you can use it ever after. And that lets me build a shim that bridges from a callback coming in from Windows, and then rebuild and reconstruct the fourth stack, push on the appropriate variables. And so this one piece of C code is sort of the little bridge that I need. In a perfect world, I would have support for arbitrary bindings, but this was easier. And that lets me initialize a window class. This will make no sense to anybody who doesn't know Win32, and then create a window. So all of this gobbledygook is hidden away inside of the thing, so you can use it without knowledge of that. In total, it's not that bad, actually, despite all of the Windows isms and the size. It's only 1,200 something lines on Windows, and the X11 one is even smaller. X11 wins on terseness. I too was inspired by Hearts. A question to Kevin and folks: would you rather with the Hearts that I show that later in the Hearts presentation? I can leave that portion of it for then. I have a small demo I can show for non-Hearts things now, or what's the
go right ahead and do it right now, because it fits very well and it's a good explanation.
All right, cool. So then let me go on, and I'll do my Heartsy demo. So for Hearts, I also wanted to use sines and cosines. Off the interwebs, I found this particular formula as a particularly nice looking heart. I had a little bit back added floating point to micro uEforth, so I decided to just, for this bit of it, use floating point, but try to avoid it being in the critical path. This particular function, you end up from the origin, you got some number of, I think it's 5 units up, and maybe it's 7 units up, and then as you loop around from t equals 0 to 2 pi, it goes around this. Not in a uniform way, and so what I wanted to do is I wanted to build up a lookup table so that I could pre-store the heart pattern and be able to draw it reliably. So what I do is I do something like, actually let me show this. I build up a table where I'm keeping track of the ranges of scan lines that I would need to draw the heart. I do it at a fairly high resolution because, as you'll see later, I have a desire to do them at a reasonably high resolution. So I draw 4,000 points going around the heart, only 1/2 of the heart, and then keep track of 1,024 bytes for the ranges. So I'm doing 1 byte of precision for the start and the end of the heart at 1,024 points. To do this, it was convenient to have CMIN character size min and max. A little bit tedious, but basically I walk through and find if if my data point falls such that I'm basically finding the minimum and the maximum point at any given scan line and keeping track of that. And for any point where there was nothing in that row, then everything sort of sits flush to the middle. And then at the very end, I go and transform it so that instead of being start and end, it becomes start and length. That lets me later go back and I take into account a scaling factor because I wanted the heart to have a nice aspect ratio. initialize the table if the table hasn't been initialized already, transform, taking into account that I might flip the coordinate system in Y, and then I can just loop through and draw each scan line of the heart scaled appropriately, and I draw the two halves of the heart. So I figure out this width, and then I'm drawing the right half and then the left half of the heart as two strips going down. And because I'm calling raw box, the scan line is being clipped. So if the heart is partway off the screen, then it will do the right thing. I can show a brief demo. Let me go ahead and move this over here. I've got several implementations of the thing, and actually there's a 32-bit and a 64-bit version of the thing. Let me start with some very simple. Very simple example. Let's just this is the bog minimum example. And so here I've got a box, and I'm moving around and drawing this. What this looks like inside, to give you some idea, is I just set up I asked for the graphic system. I set up a window that fills the screen. I initialize some colors. I have a drawing word that draws a black rectangle to cover the screen, and then draw in the corner, and then draw something at the position of the mouse. And so this isn't using any of the transformation stack. And then there's an event loop that polls and waits for idle to draw. And so it just does that over and over again. You can make it a little more complicated by, let's say this. So here I've now added a bunch of additional colors, and now I'm using my transformation stack. So I fill in the screen with black. I draw some boxes. I set up a coordinate system that's 640 by 480, but with the origin in the lower left-hand corner. I draw some gray boxes for the background, and then in a separate coordinate frame, I translate things based on the position of the mouse. When the mouse is drawn, I have several rectangles that I draw offset at different positions, and then I draw one rectangle unconditionally. So what that does is something like this. And then if you push down the mouse, you get these additional boxes. So you can sort of see how you can respond to events. Now we're working our way up to the thing. So now let's do some hearts. So I have this very simple one. Let me just show it. So this is similar kind of an idea with some of the hearts now drawn at an offset. But let's actually I'm going to see if I'm going to just oops. So, try the 32-bit for a second. I'm just curious if it's okay. Let's check a little snappier for some reason. Okay, and so then I decided to put this all into something a little more complicated. So I was inspired by, I think, one of the comments. Oh, by the way, the graph that I had earlier was drawn, in here. That was where I got the graph. But so I was inspired by, I think, one of the lines about Cupid's arrows, and so I thought, well, let me do some arrows for Cupid. And so this is my weird demo. I've got volcano with various fragments of fire, and these are just made up of lots of little boxes. And then if you click the mouse, you'll see here I can shoot. Oops, I'm getting too much fire here. Hold on, let the fire die down. Okay, I'm having trouble with that. There we go. That's oops. Demo fail. Hold on, let me restart it. I think there's a little glitch in the corner. All right, so I've got, what did I do here? All right, I'm gonna run a different precision thing. This is the problem with too many different bittage. Okay, apparently it's a bittage thing. I'll have to look into that later. But so you see, I've got Cupid's arrows here that I can shoot, If I manage to hit one of those hearts, come on hearts, come here, then I can, come on, let's do a sea of arrows, and they will pop up and turn yellow. And so I don't know if there's some symbolism here, but that's the crux of it. So
that's wild. Great job, Brad.
And I guess we could take a quick look at the code here. It's not too bad. So this is what, 266 lines of code. I use some of the structures to set up a small simulation. So there's a notion of an entity that has a coordinate, x and y coordinate, a velocity, and a type and a step. And there's a couple of different types, a heart and for one that's hit, the fire and the sparks and the arrows. And then there's a little bit of a pass to clean up dead objects so I can delete them in a loop. The arrows are an interesting trick. I build a little table to size a series of boxes to make them bigger and smaller to sort of make the outline of an arrow. The volcano is just some boxes going down. And then to draw, I just sort of set up the viewport, draw some background, draw the volcano, and then draw all the entities. And then there's some words to kick off emitting certain things. There's a tick word that advances the simulation. And when you're an arrow, it actually does an n squared thing and loops through looking for collisions with other items. And that is the gist of it. And then there's just sort of a loop for the clicking. Any questions?
I've got a question. Have you thought of adding matrix transformations to allow rotation and such to be composed with translation and scaling all together?
Yeah, definitely would be the direction to go. I think one of the sort of things that I was trying to balance with this is I wanted to see what kind of performance I would get out of my fourth core doing the rasterizer directly. And I think that if I go in the direction of things like rotation, what I'm going to end up wanting to do is use floating point more heavily. And at that point, I suspect that I would run into more of the performance issues at the boundary of the interpreter and floating point. But yeah, I mean, if you're implementing one of these properly, yeah, you want to use like a 3x3 affine matrix to do the transforms and all sort of the right things. The scaling and translation was a sort of the middle ground between that I could do with integer math readily. And I imagine you could do rotation and matrix with like a rational integer matrix or something, but without crossing the line and using floating point, yeah, it would, yeah. So, yeah, Bob, I'm not sure. Yeah, it's definitely a direction to go. And if you've seen some of my other talks, I am also incrementally thinking about more thoughtful ways to add sort of higher performance floating point to ESP32 But yeah.
That was so cool, Brad. Thank you so much. And
it was cool
to move now.